Need to move on those little ones, because my sharpener is not good. All right. Okay. So like I said, last time we worked on exponential functions, we started graphing them, and then we identified two things that transform a general exponential function. Okay. So this is kind of a summary of those transformations, right? We started building our function of a times b to the x minus h power. A value did two things, vertical shrink and vertical stretch. And it depends on the value of the A. If A is greater than 1, it's a vertical stretch. If A is in between 1 and 0, it's a vertical shrink. Okay. We also had a exponential function that with an h value, right? So we have this little h value where we minus the h value in the exponent. It moved my graph left or right. Okay. If h is negative, it goes left, and h is positive, it goes right. But remember, it's going to look a little backwards. So what we're going to do is we're going to figure out our last value of our transformations, and then we're going to start putting them all together. And then we're going to practice, get a little practice in, and work towards our learning targets. I think we're on page 6. So we're going to jump forward to page 6. All right. So again, we want to graph the parent function. Anybody remember what the parent function to y equals 1/3 x minus 2 is? Just 1/3 to the x power. All right. So now, what are the x values I typically pick for this? What have been the -2, -1, 0, 1, and 2. Okay, so let's go ahead and graph this. So the first x value I'm going to plug in is what? So first x value I'll plug in, according to our table, -2. So I have to go parentheses here. And then I have to go to the -2nd power. I hit enter, and I get 9. Once I plug in -2, I'm going to retype the same thing. But instead of -2 in for x, what number am I going to use for x? -1. I hit enter, and I get 3. Kind of the same thing. Instead of -1, now I'm going to do 0. I get 1. Okay, and then instead of 0, now I'm going to do 1. I think you guys hopefully remember. 0.3 repeated. Again, don't get overwhelmed if you have decimals. It's going to happen from time to time. And 0.1 repeated. Okay, so now we can start graphing. -2, 9 is right here. X value -2, y value 9. Okay, next one, -1, 3. So x value -1, y value 3. Next one, x value 0, y value 1. X value 1, y value 0.3. So x value 1, y value 0.3. That's probably right about here. That's about 1/3 of the way up. And then x value 2, y value 0.1. Now, once you get less than 1/3, realistically, you're just ballparking it. It's going to be just close. It's going to be right at or above the line. It's difficult to accurately graph those. Does anybody remember what this line is right here called besides the x-axis? What do we call that? Kind of funny sounding word, right?
Horizontal.
Asymptote. Yeah, it's a, and I don't even 100% know if I'm spelling that right, if I'm gonna be honest. But it's called asymptote, which means that red line is just inching closer every single time you go to the right, but it's never going to cross it. It's never going to touch it. It's just going to infinitely approach it. Good. Okay. So now what we're going to do is we are going to use this graph. Okay. We're going to graph almost the same thing, but now there's the -2. So what we're going to discover is what does that -2 do to the red graph? So we can try to find these transformations. Okay. So we're going to use the same X values. All right, so now we're going to do the same thing. Okay, my first one's -2, but then now I have to -2. So make sure you use the minus sign here and not the negative number. So I have to go -2. So that's kind of what it should look like. And I hit enter and I get 7. So it took this graph and now we're at 7. It was at 9, now it's at 7. So now we're going to do the same thing. Instead of the negative second power, now I'm going to do the negative first power. And now I'm at 1. So I was at 9, now I'm at 7. I was at 3, now I'm at 1. What do we think the next one's going to be without ever having to type it in the calculator? How'd you get that so fast?
Because one down here. 1, so just do 1 minus 2.
Yep, it's just taking your previous answer and we're just subtracting 2 every single time. So we can subtract 2 here. I'll show you how to do it in the calculator still. So here you type it in, go to the first power -2, get -1.6 repeated. Okay. And then we go to the second power, then -1.8 repeated. Okay, so now what we're going to do is we are going to graph this. -2, 7. So x is -2, 1, 2. Y is 7, 1, 2, 3, 4, 5, 6, 7. X value -1, Y value +1. X value +1 or -1, Y value +1. Here, X value 0, Y value -1. So X value 0, stay put. Y value -1, move down. Okay, here, X value 1, Y value -1 2/3. So here's 1, here's -1, and -1 2/3 is 2/3 of the way to -2. Okay, and then here's X value 2, 1, 2, Y value -1, -1.8, we'll say right there. So red and black. What did it do? What did that -2 do to the graph visually? It moved it what twice? So if I take this point here and I go left twice, 1, 2, I'm not on the graph. If I take this point, it only moved left 1, right? Okay, so if this one's 1, then this one should be moved 1. And then this one should be moved 1. I don't think this is being moved to the left. Okay, down, we can check. So I have this point down 1, 2. This point down 1, 2. 1, 2. 1, 2. So it does. Down 2. Perfect. That's the transformation. When it moves it down 2, notice that it takes the horizontal asymptote and it also moved it down 2. So now instead of getting infinitely closer to the x-axis, it's getting infinitely closer to the y value of -2. Okay, any questions about that? So a -2 outside of the exponent here moved it down 2. Knowing that, what do we think a +1 is going to do to my graph? How much? Okay, so we think that this is going to be moved up 1. Okay, and so this is the power of knowing these transformations. If you know these transformations, you kind of don't have to graph the parent function because we already know the transformation. We use the parent functions to identify the transformations, but once you start to know them, you don't have to graph the parent function. So since I already figured out the parent or the transformation of up 1, I don't have to graph this parent function anymore. Because now I don't have to do any work to figure out what that is. I already know what it is. It's up 1. Okay. So first x value I'm going to plug in. So we're going to take this. We're going to go 4 to the -2nd power. And then we're going to +1. Hit enter. 1.0625. I'm going to say 1.0625. Okay, there we go. We're going to do the exact same thing, but with instead of -2, we're now going to use -1, 1.25. Then we type in 0 as the exponent, and we get 2. We type in 1 as the exponent. We get 5. All right, and then we plug in 2 for the exponent. Should get 17. No. -2, 1.06. -1, 1.25. Zero, 2. One, 5. And then 217. You know what I just realized, folks? Plotted these two wrong. Good thing I didn't graph it. I pointed 0.0625, but I needed 1.6025. So my points need to be here and here, not down here. So I'm going to put a little red cross through those. I plotted these two wrong. Yep, I just messed it up. Okay, and then my horizontal asymptote is at what y value now? It's normally at 0. Now it's at what y value? 1. Yep. Any questions about that? All right, that's actually the last of the 3 transformations we're going to cover. Okay, so what I'm going to do now is we're going to flip right to the very front page. We're going to kind of formalize it right where we have that little table thing that we created. And then we're going to go back to page 7 in a second. A value, vertical shrink, if A is in between 1 and 0. A value, vertical stretch, if A is greater than 1. H value, we'll look backwards. It will move to the left if H is negative. It will move to the right if H is positive. Now, we've added the last one for us, and that's going to be the K value. That's exactly what we just covered. Try to squeeze it in there. I don't have a ton of space. What are the 2 things the K value does for us? Moves it up or down. How can I look at the K value right away and know whether it's going to be up or whether it's going to be down? So you might have to scroll back to our previous page and look at the two values that we had. How could we know right away whether it was up or whether it was down? Yep. When K is positive, it goes up. K is negative, it goes down. Okay, so this is going to be pretty helpful for you because part of your work that you're going to be asked to do is not only to graph. I feel confident in everybody's ability to graph here, especially with the use of the calculator. Okay, but you're also going to be asked to identify the transformations. If you know the A, H, and K value, you are not going to need to do or graph the parent function. You're just going to be able to identify them, and then you're done with that part. If you're not able to identify them and tell them, you're going to have to graph the parent function, then try to determine. All right, everybody have this written down? All right, let's go to page 6 or 7. This is what your learning target and your test work is going to look like. Should look pretty similar. Okay. Okay, so should look pretty similar. Remember, the general form these exponential functions are in is y is equal to a times b to the x minus h plus power plus k. That's a lot of stuff. That's the basic form. If you can find those numbers, you basically found the transformations at that point. So those are the first things. For me, if I'm you, that's the first thing I'm going to try to do every time. What's my A value? 4. A is 4 here. Okay. What's my B value? 1/2. What's my H value? Gotta be careful with the H value.
-1.
It's -1. Remember, H is going to look backwards. It kind of looks like it should be positive. But it's actually a -1 because the formula says minus H minus -1 is +1. What's K value? Any questions about identifying those values? Okay. Now, folks, I need to remind you that you should not just be blindly writing things down. You should be also like, listening to the things I say. Like if all you do is write this stuff down, like you're not going to learn a whole lot. Like kind of actually be listening to what I have to say. Okay. Each of these things are going to do its own unique thing. A value is +4. What does that do? What transformation does that give my graph? According to the very front page where we had those 3 different parts, what does an A value of 4 do for my graph? It's going to be a vertical stretch because it's greater than 1. For bonus points, anybody know what the scale factor of this vertical stretch is going to be? Don't overthink it. 4. All right, what about B value? B value we actually didn't write on the front page, but we did talk about. What's B value do? It's 1/2. Give you a hint. It's either growth or decay. Is this going to be a growth function or a decay function? It's a decay. If the B value is in between 0 and 1, it's decay. If it's greater than 1, it's growth. H value -1. What does that do to my graph? Look at your front page. Find the H value. How much? Yep. Yep, it's going to move left 1. H value is -1, it's gonna move to the left one. If it's +1, to go to the right one. K value -2, what's that gonna do? Down 2. All right, folks, you know what we just did? We just made it so we do not have to do this parent function at all, because we already identified the transformations. Okay, so we did say, you know, once you get used to this, you're going to save yourself some time by not having to do the parent function. Okay, I need everybody to this. As far as graphing goes, what I'm about to cover right now is going to be the hardest part by a lot, I think. Because I think once everybody gets in a routine, you're going to do great. Normally, what's my first X value? Negative what? -2. So normally my first X value is -2, right? But my graph is being moved to the left 1. So I'm moving to the left 1. So what's my first X value I actually have to start at now? Okay. I do believe that is probably the hardest part. So I'm going to go over it again right now. My graph, I normally start at -2, right? If you look at all the previous parent functions, they all start at -2, which is right here. But my graph is being translated to the left 1. So then I would start at -3. If my graph was being moved to the right 3, my first 1, 2, 3, my first Y value, X value would be +1. Okay. All right. Now at this point, all we have to do is graph. All right. And so then this is what we're going to do. You're going to take your calculator and we're going to do the same thing we've been doing a lot. And it's probably getting a little old, but that could be worse. Okay. Could be worse things. So what I'm going to do is I'm going to take 4 parentheses 1/2. Okay. And then I'm going to raise it to I'm plugging in -3, right? So -3 + 1. And that here has to be in parentheses. And the 1/2 has to be in parentheses. Okay. And then -2. Okay. And you hit enter and you should get your first number, 14. All right, does everybody remember? I'm going to try to show you a trick with these calculators. Does everybody remember how to type in this again really fast without having to retype every single little thing? Okay, ready? This is what you do. You hit the yellow second button. And then after you do that, you hit enter. And what it will do is it will retype everything that you just did. So now I can go and find the number I'm trying to change because I'm trying to change that -3 into a -2, and I just type 2. Okay, and then I can hit enter. And then this will help you go faster. Okay, and so then I'm going to do the same thing, second enter. Next number I'm going to put in is -1. And then I hit enter. Okay, here's another new trick, right? I'm going to type this in. I have to type a 0 here now, right? But I really don't want that negative there. If all I want to do is get rid of only that negative, if you hit clear, everything's going to get deleted. But if I hit this DEL button, delete, it'll delete only that one part for you. So if you need to retype something and just delete one part completely, DEL will do it for you. And I hit enter and I get 0. And then the next one is 1. Okay, and so now all we have to do is graph this. -3, 14. So X is -3, 1, 2, 3. Y is +14. 1, 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. X is -2, Y is +6, -1, -2. 1, 2, 3, 4, 5, 6. -1, 2, X is -1, Y is 1, 2. X is 0, Y is 0. X is 1, Y is -1. Okay, and so then that's about all I need. And there's my graph. Okay. What's the number for my horizontal asymptote? It's gonna be your K value. What's your K value? So that's, since the K value is -2, the whole graph's being moved down to. So the horizontal asymptote is at -2. The graph will never, ever, ever touch that value. Okay, that's what 3G looks like. Any questions about that? I did not need to do the parent function because I already identified the transformations. If you get to a test and you don't remember the transformations, you're going to have to graph the parent function and try to figure it out the hard way. Okay, let's do one more example. Then there's some monitoring progress problems, and then yeah, I'll let you go. All right. Again, if I'm you, I'm identifying all of these values. A, B, H, and K. What's my A value? It's not 1. It's 1/2, right? There's a division there. Okay. What's my B value? 4. What's my H value? Is it positive or is it -3? It is +3. That one is just, yeah, I'm just going to tell you, it's probably going to screw a good number of you up from time to time. Okay, K value. I don't know why I put a plus sign there, but I did. Okay, what's the transformations? What's my A value do? What's the A value do for me? Vertical shrink. Because the A value is less than 1. Since the A value is less than 1, it's a vertical shrink. What's the B value do for me? Growth. Because the B value is greater than 1. So this is going to be a growth function. H. I'm sorry, I didn't hear. Right 3. Good. And then up 1. Good. So these problems all in all are going to be worth 8 points. 4 points for your transformations. If you are only able to write some of these, you're just automatically at a 2. And if you're not able to write any of them, you're going to be at a 1. You have to get all 4 to get the 4. Okay. All right, let's figure out what X value am I going to be at, right? So my X value is normally starting at -2, but my graph is being moved to the right 3. So I'm going to the right 1, 2, 3. What's my first Y value going to be? 1. Sure. So this graph is going to start at 1. Do I need to go over that again? People know the class really had a heck of a time with that. Are we good with knowing I start at 1? Okay. Hey, now it's just, can you use a calculator? So I'm going to put the 1/2 in parentheses. I put 1/4 on accident. And then I'm going to type my 4 to the. So 1/2 times 4 to the, and then X minus 3 power. So here X is 1 minus 3. That exponent has to be in parentheses because I need that -3 to be in the exponent. And then plus 1. I hit enter and I get my first one, 1.03125. If it's a really long decimal, it does not bother me if you round. Because I'm not going to be able to tell if you graphed 1.03125 or 1.03. Like it's on the graph, it's going to look the same. Okay. Here, I'm going to hit second and then enter. It's going to retype what I have. And instead of 1, it's going to use 2. 1.125. I'm going to hit second and then enter again. I'm going to replace X with, instead of 2, now it's going to be 3. I hit enter and I get 1.5. Okay, and as you can see, we're getting plenty of decimals. So when you get to your practice problems and you start getting decimals, don't come up to me freaking out. It's just part of the way it works. Set of X is 3. We're going to use X is 4. Okay, hit enter. And you get 3. Replace X with 5. Hit enter, and you get 9. Okay, and then you can start graphing 1.03125. So it's right here. 2 comma 1.125. So 2, this should be just a little bit above it. Okay, 3 and then 1.5. About halfway, and then do a very good job there. 4 and then not 3. And then 5. Here's 5 and then 9. What number is my horizontal asymptote at now? What should it be at? 1, because that's K value. So K equal to 1 is my horizontal asymptote. So that graph is going to get closer and closer and closer to that red line. Technically, it's never going to touch it. We do a probably pretty bad job. Okay. What I want everybody to do now is go ahead and work on the 2 monitoring progress problems on the next page. They're the exact same thing to the best of my ability I can make it. So you're going to work on those problems on page 8, and then we'll go over the practice problems. I'll give everybody a little bit of time to work on these, and then I'll start putting these up on the board. I just keep working. I do have 4 up there, but just keep working through it. Don't just copy. I do have that one done for you though. So you can kind of start to see how you did. Okay, and then now I'm putting 5 up. So just keep working through those. Your practice problems. I'll write up on the board as well before your learning targets, if I can find the right thing. So those are the practice problems as well, once you get those done, so everybody can keep working. Otherwise, that's the end of the lesson, and you guys can just keep working on your own.